What's up, guys? Welcome to another Maker Monday. I hope you guys are enjoying these videos in this series. We'll try to keep them short, so I got my good old stopwatch sets. We'll try to keep these as short as possible. Today we are going to be checking out rectifiers and rectifier circuits, as the title suggested. So we're going to be, I've got some stuff set up here on the bench, got a scope going, got some transformers and whatnot. We're going to take some wall power, transform it down to a smaller voltage where we can make sure and be safe while probing all this. And we'll show you guys how a rectifier works, so we can take alternating current and change it to direct current and also smooth it all out to get a nice clean signal. Very simply, using few parts, just a few capacitors, a full bridge rectifier, and a LM7805 voltage regulator. So guys, stay tuned. I'm going to switch up the camera. We'll put her on the bench and we ought to check this out. See you in just a second. Okay guys, what I got set up here on the old bench going on here is our beginning of our rectifier circuit. So what I'm going to do is I'm going to put on the screen right now what we've got. We've got a voltage source here on the left hand side that is, as you can see, it says sine and it's 22.627 peak, which at 60 hertz, which that's the next number on that deal, is 60 hertz. At 60 hertz and with 22.627 peak, that's about 16 volts RMS. And we'll get into peak and RMS stuff probably in a later video, but I would like to just mention it here that that's the peak. So that's from the very tip of the waveform. So let's go ahead and we'll move to the next slide. This is what the waveform should look like. Okay, so this is going to be the sinusoid that it's going to look like, both positive and negative halves, okay, going between that and roughly 60 hertz. All right, so now back to our bench here. What we're going to be looking at is I've got a power supply set up right here. This is just a receptacle that's switched, and we should see when I turn this on, I've got the scope probe hooked up to the AC side of this, so basically the other side of this transformer. This is a small doorbell transformer. It takes the 120 volt AC North American voltage. We're looking at, I live here in North America, so we have all 60 hertz systems, and so 120 volt is the voltage that's prevalent in the residential or household area. So that's what we're going to be looking at today. If you live in other parts of the world, there could be 50 hertz systems and 240 volt outlets and things like that. But for this video, we're just going to concentrate on the North American 60 hertz 120 volt system. So this takes that 120 volts, transforms it down to about 16 volts. I'm talking all RMS here. So what we should see when I flip this on is we should see that sinusoidal image come up on the scope. And there it is. So now if I zoom in on the scope here, you can see that 60 hertz waveform, okay? And it goes both positive and negative, okay? So now let's back off. I'll show you what I'm doing here. Okay, so now what I'm going to do is I'm going to move the scope probe. Let's shut it off first. I'm going to move the scope probe to the DC side, or basically the rectified side. So, and the reason I'm not using two probes is because the ground reference on these probes is the same, okay? So I can't tie an AC ground with a DC ground. It'll cause problems. So what I'm going to do is I'm going to reset the scope to DC coupling, because I want it to be, because I'm measuring a DC signal now. And then I'm going to turn it back on. And what we should see is when I bring up this next slide, what we're going to do, this next slide will show you, all right, we're going to add the rectifier to it, as you can see. So the rectifier is a 4-diode network where we're going to rectify out. What this basically will do is it will basically not allow the AC waveform to go negative. It will only stay positive. So we should get this next waveform. So as you can see, the waveform is now, the bottom cycles are transferred to the top. So now everything is a positive sequence. So what that basically does, RMS wise, which is an average, on average you should get what the peaks are roughly, probably a little less, but still you'll get what the peaks are, is what the DC voltage you will see is. So now back to our bench. Okay, so now I'm going to flip it on and you should see that same waveform come up. And there it is. It's a little distorted, probably some parasitic capacitances and whatnot, but as you can see, it's all above the zero line, okay? So there it is. So let me turn that off. And now I'm going to show you the next trick, Okay, the next trick is we have to smooth that out because that's kind of a rough voltage. That's kind of a very rough way of doing power. So what we're going to do is we're going to add in, I'm going to connect in this capacitor right here. So we'll flip up the next slide. Okay, so that's going to be the capacitor. And so what that's going to do is that's going to smooth out that DC waveform. Okay, and it should look something kind of like this. Okay, I mean that's not perfect, but it smooths it out a little bit. Okay, so it's going to smooth it on out to where it's not so bouncy. Okay, so let's go back to the bench. So now that I have that connected, we're going to turn it on. There we go. That looks a lot smoother, as you can see. Can you guys see that? Here, let me zoom in. You guys see that? See? That's nice and flat. Okay. Now the problem with this is it looks nice and flat, but the minute we add a load to it, you're going to start to get some ripple. Okay, so what I'm going to do is we're going to further regulate this out, and we're going to move on to my next slide. So as you can see, okay, the next thing that we're going to do is we're going to add the 7805 voltage regulator because we're actually above 5 volts, and let's say we're making something for microelectronics, for a microcontroller or something. We need this voltage regulator. Now I just to show you a load, I just put a 100 ohm resistor on it. What we're going to actually do is probably put a LED on the end of it and show you that you can light the LED and get 5 volts on it. So what we're going to do is we're going to add some capacitance, and I just threw some rough capacitance numbers in there. I hate to tell you this, but I've borrowed this drawing from another video that I did. So the 1 micro and the 0.1 micro that's on the input and the output is going to be replaced by a 330 microfarad on the input and a small 1 microfarad on the output, just for the smoothing of the regulator. So anyway, when that's all over with, it should look like this. And this should be our final signal, and we should be able to light an LED off of that. So what I'm going to do is I'm going to go ahead and put that LED on, okay? So I'm going to hook all this up, and through the magic of camera magic, we will kick back up and it'll all be put together. Okay guys, through the magic of time, we have come up with the connections of all of this. So what we got going on here is, I'll show you with one of my tools here. We've got an LM7805 5 volt voltage regulator. We've got the input coming from our rectifier. From the DC side of our rectifier comes to the input. Ground goes back to the negative side of our rectifier. We also have our 330 microfarad capacitor. Now you got to watch this. Capacitors come in voltage ratings, so you got to make sure that whatever voltage is pumping out of this guy, which I believe it was like 20 some volts peak, which is coming out of this guy, you got to make sure you size the capacitor. That's why this guy's so monstrous. This is a one that I had laying around. I think it's like a 50 volt cap. You don't really have to go that much, but you just definitely have to have at least 25% more than what your actual voltage is. It's better to go ahead and do 50% more actually, but you can get away with 25%. So you definitely want whatever voltage that's coming out of this rectifier after it's been smoothed by the smoothing cap. And that's another thing. The smoothing cap needs to have the voltage, a voltage rating that can take whatever voltage is coming out of this. Otherwise, what's happening is this capacitor is taking up the slack between all the bouncing that's doing because of the 60 hertz waveform. What it's doing is it's actually, you cannot change the voltage across the capacitor instantaneously with time. It has to discharge, right? So that's what this guy's doing. So it's getting beat on pretty good. So you definitely want to make sure it's rated to take the voltage that you're dealing with, okay? So usually at least 50%, you can get away with 25% more, but at least 50% more. And sometimes in things where I want to make sure it's really robust, and if I have the space, I'll even double it. So if it's 20 volts, I'll make it a 40 volt cap or 50 volt cap or whatever it is. So you want your voltages of your caps to match. Now on the output's only 5 volts, so I don't need as robust of a capacitor. But on the input sides, there's lots of stuff. Now this is also done without any protection circuitry. I may do a different video on that showing you how to put MOVs and other things and clamping Zeners and things like that to actually put protection on a circuit just in case if this guy bounces really high or something, or there's a surge or something happens. This is just a basic rectification circuit, okay? So now what I did was I added as our load an LED on the end of our 5 volt rail. So now when I turn it on, we should see the LED light up, and then I'll back off and show you the regulated output on the scope. So let's go ahead and fire this up. And there's the LED. So the LED does light. Let's back up here and let's move up to the scope. There it is. So there is our regulated output. And as you can see, hopefully you can see that. Let me steady the camera. It's about 6 volts or so, roughly, which is coming out of there, which, that's pretty good. That's pretty good. I mean, for an LM7805, I mean, that's pretty good. You could take and do, some more things to get it regulated even further. But for this instance, like I said, this is just a demonstration. This is just Maker Monday. So we're just going to check that out for now. That's a good, rough rectification circuit. Just a simple rectifier and a 7805 voltage regulator to regulate the voltage to 5 volts. That's a simple one. Well guys, I hope you enjoyed that quick little tutorial and glance over of a simple rectifier circuit. I hope that you enjoyed this. It was actually quite fun to throw together. Just like I said, I think that's the way we're going to do these Maker Mondays. We're just going to throw little tips and tricks out there, simple little small projects, things like that to show you guys different electronic stuff every week, starting on the wonderful day of Monday. So guys, hopefully you have a wonderful Monday. If you're watching this in the morning, if you had a wonderful Monday, then this is just the icing on the cake. And if your Monday wasn't that great, well, hopefully this helped out with it a little bit to put a little bit of a smile on you guys' faces. Thanks a lot for watching. Take and share this video. Also, if you share it on Twitter, do the hashtag Maker Monday. That way I can see how it's trending and see if you guys are really enjoying it. Give me feedback. Throw some comments down below. Let me know if you like this concept. Let me know if you like the content or what other content you would like to see right here on Maker Monday. So guys, have yourselves a wonderful Maker Monday. Keep making, keep building, because that is what it's all about. The fun of electronics. Guys, take care, like, subscribe, share, all that jazz. And with that, I'm out. Have a good week, everybody. We'll see you next time.